Hello, and thanks for having me for this keynote. I'm Haddadi. I'm a reader in human-centered systems here at Imperial College London. I also work for Brave, the privacy-focused browser. Over the last decade, my research has been centered around privacy in personal data and network systems. Especially in the last few years, I've also been looking at privacy and security in consumer Internet of Things devices. Over this keynote, I will look at some of the challenges that we've been facing in building private and scalable systems. And I'll talk to a number of expert individuals in this space to see what the potential solutions can be. I hope you will find it useful. Today, whether we are browsing the web, using apps on our smartphones, or sitting in our own living room, we are surrounded by a variety of connected devices and systems, providing a range of services, while collecting a large amount of personal data about our behavior, movements, activities, and interests. Researchers and entrepreneurs have been working for over a decade to bring trust, security, privacy, and resilience to the everyday interactions that we have with the web and connected cyber-physical systems around us, as you see. Some of our novel solutions have been failing or not quite taking off on the adoption curve, though often not on technical merits, but sometimes on other factors such as complex economics or poor usability. For example, there have been some success stories. Take ad blockers or browsers like Firefox and Brave. But are these the answers to privacy on the web? If we think about the end-to-end interaction that we have with these services, maybe ad blocking and economic incentives solve a part of this problem, but in the long term, I'd love a future where we can have resilient, reliable, private, and secure personal data systems in the next decade. Online tracking and targeted advertising have been the primary way of generating revenue in the mobile app space and on the web for over a decade now. But how does this translate to the new era of IoT and all these devices entering our households? In order to test this, we utilized two testbeds, one at the UK and one in the US at Northeastern University. We set up over 100 devices on these two testbeds. And we thought, let's look at the destinations that these devices across different categories contact and who do they talk to. So we noticed that we had a large number of cameras, home automation devices, smart hubs, and home appliances. And we noticed that majority of these devices actually contact destinations which are outside their initial and primary privacy jurisdictions. To make the matter worse, at an ISP end, you really cannot detect where these devices are, who do they contact, because the connection of these devices goes through dedicated infrastructure or sometimes goes through third-party clouds. There's data sampling, there are middle boxes. So this generally makes the whole space more complicated, and it makes tracking these devices and their behavior much more sophisticated. Yet we see that these devices basically talk to a large number of destinations at different rates. So we really need to do something about this space as well. One of the main pillars of my research has been the question that can we build trusted, scalable, and human-centered network systems? Some of the objectives of such systems could be to, let's say, perform accurate and personalized analytics across all the data that we have and personal data that we have on our devices, the ambient and IoT data around us, or our digital footprints on the web. Importantly, how can we do this without jeopardizing the individual's privacy and security? So what do we know? We know that there are generous resources on today's devices. All of our phones come with generous memory, and some of them come with GPUs and TEs and motion coprocessors and all that, and a variety of sensors. And at the same time, the app developers and manufacturers are constantly on the chase for better models to do better behavioral detection and analytics. In the meantime, as researchers and as ecosystem developers, many of us are busy trying to find out privacy leakages or to identify security risks. In the last few years, there's been a large number of personal data system projects in this space. For example, projects from MIT, from University of Oxford, from Cornell Tech, and also from industry like Google, for example. And majority of efforts in this space are around a three-way optimization in a way. That on one hand, you're kind of you have privacy and security. On the other hand, you have the utility and value of the data. And finally, for everything that you do, there's a cost in terms of battery power, for example, on devices, the bandwidth, depending on how much data you send, at what granularity, and all of that. So myself and my team of collaborators in the last few years, we were working on the DataBox project. This was an example of a data management system where our idea was that use personal data containers on the user side to curate data at the user side and then to try to run models on the user side. So for example, if you have data from social media feeds or from users' devices or IoT devices in their home, this data can be locally aggregated and cross-data analytics can be done in a way that you have trust and you have control over which applications access which pieces of data, at what granularity, and for how long. This was a pretty large open source project. We worked with quite a few industry partners, including the BBC specifically, and the idea was to really roll this out to a large population site, at least in the UK. One of the bottlenecks around this was the complexity of developing such a data. Because once you go beyond a single individual and you want to look at data for, let's say, a household, things get complicated pretty rapidly. And this was one of the showstoppers for us to get really large scale traction with the DataBox. So one of the questions that I had was, is thinking around having a container for personal data systems, is that the right approach? Is that the right initial building block for this work? So the question I had was, are containers the solution to our storage problems? To find out, I thought I'll go to Cambridge, to the container man, Anil Madhavapedi.
Thanks for the question, Hamed. I think the best way to answer your question is to take a step back and figure out what it is about the current internet that makes it so successful. We use the internet primarily for one purpose. That is, we type a name into a browser, and then something happens on the internet, and it goes off and fetches the content that we asked for. No matter where we are in the world, which country, which location, which VPN, whatever it is, we can get access to yahoo.com or google.com just by using the same infrastructure. But then when you start thinking about what you'd want from a personal data infrastructure, it's actually exactly the opposite. If there are 6 billion people who potentially have access to my personal data because it's on the internet, we're spending all of this time trying to engineer a system that prevents those 6 billion people from getting access to my data. So I started thinking about this in a different light a few years ago, which is, what if we engineered a new internet that isn't layered on top of the existing one, but instead is fully human-centered? That is, we're starting from scratch and trying to figure out what the world might look like if you have an internet per person. And when you think about it in these terms, then you get a new set of constraints when designing the next generation networking infrastructure. The first constraint that we get is that as a physical person, I tend to be only in one place at one time. And even though I could potentially be accessing this data from all over the world, there's actually just a very few set of locations where I could gain access to this stuff. And similarly, when I interact with things that might require my personal data in many situations, this also requires physical access. For example, I could imagine going to my bank and getting a physical token after authorizing myself, then using that token for the next few years in order to do anything relevant to my bank. The first thing you'll notice about this is that this is not a decentralized system. This is, in fact, a centralized system that is built with me as a centrality, and with you as a centrality, and with anyone else holding their personal data as the center of the universe for that particular internet. And then later on, we know that we can build centralized systems with a high degree of reliability and a high degree of usability. So that's what we should focus on. We shouldn't be trying to make this a decentralized system with lots and lots of choice. And the second thing that is unique to this whole world is one of identity. So when I used to work at Imperial College in the early 2000s, I did my undergraduate there in the late 90s. I have a number of different accounts over there, but those accounts have now expired. But all of the photographs and the fun memories and all the personal times have to persist with me. So we need a different model for how we deal with identity in this world of personal containers. It can't be one where some third party gives us temporary access to an identity service that then expires after a few years. It's got to be something that is genuinely a lifetime concern. And also critically, once we stop using that service, we've got to somehow expire this system so that it stays with us and continues to work, even though the actual system behind it has disappeared. So these are just two of the constraints that you start thinking about differently when you think about how to build an internet per person instead of an internet that is per website or per company that is trying to use it. So my challenge to CoNext is, we already have the technology to make this work. The banking system I described earlier could be done with one-time pads, something that dates back to Roman times. The system of physical networking when I'm in my house, we have all of the different pieces with Zigbee and Bluetooth LE and so on, but no one has pulled that together into a system that is super easy to use, involving tangible interfaces so that I can just touch one thing to another. No one has, for example, let me put my personal data into a locked box where I have a physical key to unlock it. These are all concepts that align with how people protect their existing physical data, and one that we should make work as seamlessly as possible with personal data. And then once you have these basics in place, the rest becomes much easier. For example, could we have digital trust fountains that use modern distributed ledgers and cryptocurrencies to authorize the fact that I've been, and attest to the fact that I've been in a physical location? You could imagine whole networks of multi-spatial granularity, so that one could authorize that I'm in my house, one could authorize that I'm in Cambridge, one could authorize that I'm in the UK, and all of these run at different levels of trust and granularity. All of these technologies are possible. But what we need to do from a networking perspective is to build the architecture where we can plug these technologies into one unified whole to build an internet per person. I'm looking forward to seeing what comes next.
Identity. I think Anil touched upon a very important topic there, which has been bugging my mind for a long time. So I was issued with an identity on birth, the birth certificate from Iran. Since then, I had acquired a bunch of other identities, a bunch of passports, and then slowly payment identities, credit cards, driving license, university ID, and things like that. These are physical, hard-coded, and partially protected ID systems, which can be verified by a central authority. Obviously, if we are moving towards large-scale, planet-wide, decentralized systems, which can enable us to have things like immunity passports, or national IDs, or decentralized payment systems, we need to be able to have trusted yet verifiable, and also more importantly secure ID systems. However, what we cannot rely on is continuous connectivity. I can't always be online. At the moment, for many of my ID systems, Apple ID, Facebook ID, Google ID, Open ID, and a bunch of payment systems, I need to be online, and a third party or a verified authority need to be able to attest that this ID is correct. However, this is not always the case, and we cannot always have that assumption. So where do we go from there? And how can I use my devices, for example, or some sort of tokens to reach a consensus on the identity issue? To answer that question, I thought I'll go to the man himself, Professor John Crowcroft from University of Cambridge. So John, we've been trusting the governments for centuries around ID systems and currencies, and now we are shifting this trust to Apple and Google. Do you think this is sustainable for the next generation of systems?
Yeah, this is a really good question. That basically, having large centralized organizations trusted by a population depends on them seeing physical evidence that the organization isn't going to go away or change its mind about how it does business. And so banks have nice big buildings, and the Bank of England owns, great big mints, and the same in many countries. And you see the same in other organizations. So as you go more virtual, you go more online, companies like Google and Apple and Microsoft and so on have all this virtual infrastructure. You don't see it. So trust can fail instantaneously. And the same is happening with governments. Of course, we've diverted trust away from government as we see that their interests disconnect from the people and so on. And everyone's got experience in some part of the world of a government going from good to bad. There's no reason to believe a company won't do the same. Companies have built-in policies, they have shareholder agreements, whatever, but they can all suddenly change, to increase shareholder value. So there's no special reason to give extra special status to a company just because it makes more money than a nation state. That's irrelevant.
fair enough. So do you think if we go for the new range of distributed and decentralized systems, can they scale to billions of people?
So decentralized distributed federated systems can scale because we can have very large numbers of them. So we don't need one big system to rule the world. We can have many, many systems, and you can choose which one you use for the activities you have with your social group, your friends and family, your colleagues, your health providers. You can actually change them as often as you like. That kind of world is very easy, and we have mechanisms that scale out for supporting those sorts of activities shifting around, and it's quite challenging. We need to make sure these things are seriously robust, and there are certain approaches which I'm not convinced by. I don't think things like proof of work are great. I'm not convinced by reputation networks, but maybe if we go through the process of building lots of these, we'll see which are the most successful, and if we have this kind of very easy flexibility of moving between them, as for example, I just moved my internet provider, my electricity and gas providers, it took 3 minutes. So I could change my trust provider or my currency provider as quickly. Then we could see, we could have sort of competition, and this system would not be full foul of the risks or the temptations for large centralized agencies tempted to become evil.
Mm-hmm. And one problem is that a lot of these systems are relying on continuous connectivity and having internet all the time. Do you think we have to move to a little bit of an intermittent systems, because obviously not everywhere in the world you always have internet?
So this kind of always-on idea is really interesting. So if you go back hundreds of years, you might take weeks or months or years to get approved for having a loan. Indeed, it can still take weeks, in fact. If you look at online systems to get a transaction approved, or use some ID system to prove an attribute about yourself that you're over 18 and therefore you're allowed to do X, Y, Z, those systems have tended to rely on always being on. But that's not really a requirement for that. Again, there's a kind of trade-off in the risk you're prepared to take. You can carry some pre-approved tokens for payment. This is being designed several times over very nicely and demoed in practice in the wild. And those systems can operate disconnected for a large amount of time, find connectivity, upload and reach consensus with the rest of the world, and then go back to operating decentralized. So we've seen that in some countries now where we have decentralized and not always on systems. For ID, Estonia, for example, other countries have actually written down designs and that operate that way. And when you federate systems, you may find the same thing happen. So in fact, a decentralized system is just a kind of extreme version of federation. And at some point, disconnected operation is required. You just do not have 100% coverage. We don't want the world to stop working. We don't want commerce, entertainment, health, and so on to stop operating. So we better have a system that works when you're not always on. And we have existence proof of some systems that do that. So I think that is the way forward. We'll see systems deploy, as usual, in developing regions already before the developed world, because they have to work there. Disconnected operation must work because they don't have the coverage in some countries that we mostly enjoy here. And so they will leapfrog us, as they have with mobile payment. I think 25% of GDP of Kenya moves through M-Pesa, which is a mobile payment system, which is always on, but it didn't have to be. There are alternatives that will work with disconnected operation, and then as soon as you do that, we can move to many providers of such systems that are fully decentralized as well.
Brilliant, thank you very much. Recently, there have been great advances in trusted execution environments. TEs provide an isolated, secure chunk of memory that can be used for executing specific commands, storing sensitive data, or storing sensitive models. We've recently shown that TEs can be used for partitioning models, so you can even store and execute larger models where you cannot fit the whole model inside the TE. And by partitioning, we can see that we are able to provide good level of utility while maintaining the privacy of the user and the model. And this actually comes at very insignificant cost and overhead for the system, both in terms of the memory and in terms of the CPU usage. So the question is, are TEs the silver bullet for providing security and privacy in edge devices? I was not sure, so I thought I'll ask the expert, Professor Peter Pietzuch of Imperial College London.
Are hardware security mechanisms such as trusted execution environments the answer to trust in personal devices? I don't think that hardware security mechanisms are the single solution to solving all of our security and privacy problems, but they can act as an important building block to achieve overall more secure solutions. Hardware has now become the new software. So just because a feature is implemented in hardware doesn't make it fundamentally secure. And we've seen many examples of attacks on TEE implementations that were proposed recently in the literature. At the same time, hardware security mechanisms can form an important building block. So we should be solving security problems using a defense in-depth approach. And here hardware security mechanisms can play an important role because they create additional obstacles for attackers that they need to overcome, resulting overall in more secure designs. So I do think that we're moving to a world in which hardware security mechanisms become normal and become widely used, similar to how we use hardware acceleration as a feature to achieve better performance.
Thanks, Peter. So it looks like on the path to building trusted, scalable, and human-centered network systems, which have been our original challenge, there are quite a lot of obstacles. And there are also a large number of missing pieces that I'm not even covering here, including human factors. People at UCL, Mixed Reality Lab in Nottingham, and Cornell Tech have been working on economics incentives, regulations such as GDPR, ethical issues of dealing with personal data, business models that people like Nicolas Lotoris in India have been working on, encryption mechanisms that folks in INRIA and Cornell have been heavily working on, reliable, large-scale data-intensive systems. People like Jana Jigeva in TU Munich, Frank McSherry, and folks in Princeton, Mike Friedman, have been working on these machine learning mechanisms, testing and verification systems that people at Max Planck Institute and Facebook have been working on, and standards. So there's a lot to cover here until we can have reliable systems. So I'm not sure, do we give up or is there hope? Even after securing all the devices on the edge and encrypting the data and securing the transport protocols, we still somehow need to transmit all this data on the internet. Yet, even today, we still see large-scale DDoS attacks, botnet attacks, and security issues in inter-domain routing protocols. Folks like Sharon Goldberg in Boston University and Adrian Perig in ETH have been working for years in this space. So I managed to get hold of Adrian to ask him the question that, Adrian, you've been working for years to give us secure inter-domain routing, yet we are yet to see global adoption of these standards.
Yes, indeed. We've been working since 2009 on the Scion Secure Internet Architecture. What I've learned from previous projects is that success sometimes needs two ingredients: effort and persistence. For instance, in the SafeSlinger project, perhaps we didn't put in enough effort. So even though we had one of the first secure messaging applications, few people are using it today. Another example is the Seeing is Believing project, where we simply gave up too early. So in contrast, others' persistence was rewarded with adoption as a second factor authentication system, which is in use today. So with Scion, we're not giving up, and our effort and persistence has now paid off with real-world deployment. So for instance, last week we heard from a large ISP that they're also deploying Scion, and this is now the 8th ISP that offers native Scion connectivity to customers. So the main points here are that effort and persistence eventually pay off.
Many thanks, Adrian. It's great to hear and be reassured that we are on the right path for making the internet more secure. Because I think there is genuinely great interest and great outcomes in having secure systems and private sensing systems. One of the projects that we are currently working on is for the UK Dementia Research Institute. The idea is that if we can provide affordable, scalable, reliable sensing systems at home, many early stage patients suffering from dementia, or generally the elderly, they don't need to live in a care home. They can live a happy and independent life and be able to receive personalized interventions and monitoring from dedicated medical teams. What we need is really a sensing system which is number one, reliable. For example, in the image that you will see, we have a large number of sensors in this household. We have sensors under the bed to monitor the sleep quality. We have proximity sensors. We have sensors under the plates, at every door, at every plug. This might be slightly overdoing it, but the idea is to understand that can we monitor, for example, the behavior of the elderly and be able to provide timely interventions if, for example, some abnormalities are observed. Of course, this comes with strict privacy and security requirements and with regulation. So what we are doing is that we are collecting majority of the data across a large number of different sensing sources, from sleep quality and behavior sensors to medication dispensers, even things like urine infection tests and robotics, personal robotics data and home assistance. And we are bringing this data together using local aggregation, and we are trying to do as much of the processing as we can locally. So the idea is that you only send to the cloud general aggregated inferences. So this data can be integrated at the health system. For example, in the UK, we have the National Health System, and be able to provide personalized interventions. If systems like this are successful, potentially hundreds of thousands of dementia patients and the elderly can afford great care and be able to basically benefit from the health system without having to live in a care home. One of the directions that we are exploring is also using population-wide statistics and using advances in deep learning, for example, looking at things like federated learning to provide personalized models for individuals, but also to be able to do population-wide statistics and analysis with privacy controls. So the idea is that if we have infrastructure which is reliable, which is secure, and we can really trust the data, and we can also provide continuous monitoring, we really can have systems which are beneficial to the individuals and for the health system overall. So we can make good, reliable network systems. But what about the actual data that goes into these systems? How can we make it scalable and secure? I'm clueless here, so I went to the expert, Professor Jana Jigeva from University of Munich. I asked Jana about the scalability and database challenges. Her opinion was that these are not going to be very dynamic and very large databases. Basically, they will be as big as the population of the Earth, which in database terms is not huge. The actual problems are going to be, how do we secure the data? How do we make sure that the right authorities and the right people within those authorities can access the right pieces of data? So how do we protect data access, basically, and how do you enable fine-grained and detailed access control mechanisms? For payment system, obviously, there's been a lot of work in distributed ledgers and their scalability. So Jana's view was that the main problem today is that how do we group people and form the right interacting entities into groups and clusters and hierarchies so we can really help with the scalability issue. And that's very interesting because I think scalability issue has been a big issue in distributed ledgers and in payment systems, but hierarchical methods can help. So that brought me to my last question, that with building all these systems, what are the actual obstacles from having these systems out in the wild? Are there any economical issues, or when are we going to see actual adoptions? I had these questions from my last expert, Nikos Latoris from India Networks.
Technology adoption is a slow process, especially when it has to do with safety. Think of safety belts or airbags, for example, and especially when the consequences of failure to adopt such technologies are paid later in the future. Think of bad nutrition. And even more especially when changing things requires changing established habits and a complex underlying economy. So that's the answer. What can we do about it? Well, we should be patient, and we should continue doing great research, but not forget to do outreach and explain all these things to people.
This nearly concludes my talk. So we've covered the large number of challenges in this space. We've looked at some failures and some successes, and we've gone from identity systems to home IoT devices. Generally, what I wanted to show is that building user-centered systems is hard. You have complex challenges from the economics and incentives, but there's also great opportunities. You can do great things from payment systems and decentralized COVID tracking and immunity passports to be able to really useful health systems for the elderly. So we do need to spend time to design and implement these systems carefully and to put the user and the individual at the heart of our design in order to understand their requirements and prioritize them over economic incentives. Edge computing and advances in client-side analytics, for example, federated learning, model pruning and model compression, and techniques like that, and trusted execution environments, which we mentioned, they provide timely enablers for us to be able to optimize between privacy, security, and utility on the data, specifically in the personal data ecosystem. Some of the papers I mentioned are available on my website, and I would also like to acknowledge and thank a large number of collaborators and friends who've been very helpful in the discussions on this keynote. Obviously, any errors remain mine. Thank you very much.